right, welcome everybody to the first day of class after Easter. We are going to be entering the matrix today. We're going to be talking about a bunch of really cool things today. We've got 5 different learning points. I'm going to split the recording into 5 different parts for easy access on YouTube. First thing we're going to be talking about today are lambdas and anonymous structs, anonymous functions, things like that. Names are one of the hardest things in computer science. You'll see me like struggling sometimes to come up with a good name for a variable. Like if I have to come up with a name for a variable of type point here, point is just, some point in 2-dimensional space, got an x and y coordinate. I'm going to call it P, probably. I don't know. That's all I got. Names are actually really hard. And while I sort of humorously struggle with them in this class, there's actually a more serious issue when you're dealing with a large code base. Imagine you've got 100 million lines of code. Then you could run into a problem where you're going to go make a point class, and somebody's already made one, but it's not a point class with double x and y, it's integer x and y, or it has nothing to do with Cartesian coordinates at all. It's a point like a period, at the end of a sentence. You can actually kind of like run out of names. And so C++ has various facilities for allowing you to make things without names, which seems really weird because it's like, if I don't give point a name here, how can I make a variable of, you know what I mean? Like, how do I, like this, it doesn't seem possible for you to be able to make a variable of the point class without having the name point attached to it. But check it out. I could say struct, don't give a name, and just say double xy, just like that, and name it p. And then I can say p.x equals 10.1, p.y equals 20.2, and I can see out p.x and p.y however I want. So I have just made a variable of a type that doesn't have a name. It's an anonymous struct. And so you can see that it's actually called anonymous struct if you try like counting it, because there's obviously no double left arrow operator for it. So if we try compiling this here, we're going to get how many lines of error messages? This is one of the worst things about C++, by the way. We will get 329 lines of error messages because it couldn't find a double left arrow operator. So yay, good job C++ on that. But if we look at the error messages, go to the very top maybe. Let's see here. Let's see. Yeah, you can see right here the name of the type is main : unnamed struct. So that's the official name of the type of our boy there, is unnamed struct. Okay. So yeah, you can do this if you just want to make a one-off class that it doesn't really matter the name. You're not going to reuse it, things like that. If you want to think philosophically about why you need names for people, it's so that you can call them again, right? I was just on some New York subways this last week, and it never once occurred to me to walk up to people and be like, hey, what's your name? Nice to meet you. My name's Bill. Because I'm never going to see those people again, right? The only person I'm going to see on that subway again is my daughter, and I know her name, as it turns out. Don't mean to brag, but I do. And so, but yeah, it would be really weird, right? Like if you go up to somebody like, what's your name? You're like, why? Why do you need to know my name? Why are you going, like, what are you going to do with my name? Are you going to talk to me again? Why are you talking to me now? It's just really strange. And so we usually just are completely anonymous to people in public when you have no call to use them again. But if you are going to use them again, like we might in fact make mini points. We could make a point P1 and point P2 and all this kind of stuff. We have functions that take points as parameters. We could make a dot product operator. The dot products things together. You guys understand? So when you're going to use things multiple times, they probably need to have a name. But if you got a one-off thing, like, knock yourself out. You guys understand this anonymous struct concept? And where you're at right now, it's like I know all my classes in my project, but then you go to work for a company and you try making a point class, and there already is one. You're like, all right, I'm going to make my point. Nope, that one's taken. Point two. Nope, that one's taken. I mean, just think about this. If you have a function, like if you're working for, any large company, there's hundreds of millions of lines of code. Do you think somebody at some point has made a function called foo? Just somewhere within the 100 million lines of code. What do you guys think? Do you think that just somewhere out there, there's just a function called foo somewhere that somebody just threw into the global, namespace? This is kind of like hanging out there. Yeah, it depends on the practices of the company, right? But it would not shock me, because I've had this happen to me before, right? Like I'll join some large code base and I'll make a new function name and I'll call it like find minimum point, and it's like function with that name already exists. You're like, what? Find minimum point exists? And I look at it and it's not the same thing that I'm trying to do. And I was like, so I need to come up with a new name, and I'm just like, man, it sucks. All right. So as it turns out, you can actually make functions without a name also. And like, really? Does this work? Nope. Can't do it this way. If you want to make a function with no name, then you are going to need to do something like, let's make an array here. Points. Okay. And none of them are initialized or whatever, but just for the sake of argument, let's just say we're going to sort them. Sort r to r plus 100. This code will not work, right? Do you know why I can't sort this array? It's probably some test function that hasn't been used for years, yeah. So why can I not sort this array of points? Does C++ know how to sort some new class that I just made called point? Yeah, no double left arrow. No less than operator, let's say. Single left arrow. Right? So we could do this, right? You can see this thing hanging out here. Use the spaceship operator. Looks super cool. It'll automatically generate a sorting function, less than operator, to sort for you that will sort them all least to greatest on X first. If there's a tie on X, it'll sort on Y. Spaceship operator is great, but it's not always what you want. You don't always want to sort things in the order that, the member variables are. Quite common. In fact, you'll have different ways of sorting things. Sometimes you'll sort based on, zip code. Sometimes you'll sort based on income. Like it's quite common to want to sort things in different ways. And so in C++, we can pass a third parameter here. And so right here, where I'm typing random characters, normally you could put a function in here. Like I could put a function called comparatore. I don't know. And then I'm going to have a function called bool comparatore that's going to take in a const point by reference p1, const point by reference p2, and it's going to return p2.y is greater than or equal to p1.y. So basically, it is going to sort all of the points in the array such that the one with the highest y is first going to lowest y. And x's don't matter in the slightest. So that, whatever. And so if I have a comparator function like that, it's Italian, a comparatore, I don't know, then you can do that. Do you guys understand this? You've seen this before with sort. So you can pass a third parameter in and make a custom sort function that'll sort, however you want. In this case, y is greatest to smallest. Are you guys familiar with this concept? Third parameter. Okay. Here's a problem. If I've got 100 million lines of code, I've probably got a function already called comparator, right? And then I'll try like comparatore, and then I'll try like, oh shoot, that one's already taken. Comparator 2, dang it, that one's taken. Comparator by max y, nope, taken, dang it. There's actually, arguably, a better way of doing this. If you are only going to use that function once, we can use a lambda right here. Okay? And so this syntax right here, the square brackets, smooth brackets, and curly brackets, is the sign that we are making a lambda function. A lambda function is a function that has no name, but it can still be passed as a third parameter into the sort function here. And so we're actually going to write a brand new function and pass that brand new function in to sort, then it goes away. And we don't have to pollute the global namespace as a result. And so it's going to look very similar. It's going to take in const point p1 by reference, thank you very much, const point by reference p2, and it will return p1.y greater than or equal to p2.y. So let me format this maybe a little bit differently here, and here, there. So you can see this is the third parameter. It's after a comma, and it's still within the function call. So we're actually making a new function and declaring and defining a new function inside of the third parameter of sort, and we're passing it to sort, and sort will very happily use that lambda function we passed in to sort the array greatest to smallest on y. And we don't need to create a new global function. We don't need to make a name for it. It's great. And every time we want a different sort, we can just basically copy and paste this code and change whatever it is we're sorting on. If we want to sort by last name, by first name, address, zip code, income, whatever, we can just make it just like that. And as long as we don't use it a second time, this is probably ideal. Now, if you have a function you're going to be calling in 10 different places, give it a name, right? Like that's why we have names. We have names so that we can use them a second time. So if you have a function that's being used all over the place, yeah, give it a name, call it, whatever. It's fine. Figure out a name for it. But if a function's only being called once, this is arguably a better way of doing it. Now, a lot of people hate lambda functions because they look ugly. The syntax is like, let's be real here. This is a weird looking syntax, right? Like that's a strange looking boy right there. You know, that boy ain't right. You know what I mean? So it looks like alien, hieroglyphics from Agents of S.H.I.E.L.D. But it's actually a function. What's a function do? Nothing. It's the equivalent of me writing void to no name like that. This. Let's see if this. Yeah, right. Kind of looks similar, right? Takes no parameters, has no function body. Here you can see it does take function parameters, and it does have a function body. Right? You might think the square brackets is the name. Square brackets are kind of weird. There's something called lambda capture, where if you have a variable out here that you can like lambda capture x and capture by reference if you want to, and use it inside of here, x plus what plus or something like that. You can do something like that if you wanted. And that allows you to bring variables from outside the scope into the lambda. In this case, x would be basically counting how many times this lambda function got called. So, in case you're curious, you can see, you can instrument it. Whatever. I don't use them that often. And they're useful. It's just most things I just pass them as a command parameter, function parameter themselves. Okay, now what if we wanted to save this lambda and reuse it? Could you pass x as a reference parameter? No, you can't. Not in this case, because sort very specifically takes something that takes these parameters. And so if you pass x in by reference as the third parameter, sort won't recognize it. It's got the wrong signature. So you have to do that using lambda capture. But usually, I don't want to say usually, but it's sort of There's uses for it, but I personally don't use it that often. I don't know. Personal preference. But so if you want to make a function you're going to reuse, but you don't want to make a global function, right? You just want a function that exists here in this scope. You can do it. So I don't know, hello world or whatever. So here we have a function, no name, takes no parameters, returns no value, and it prints out hello world. We can actually save this lambda into a variable of type function. And function could be passed like as a third, like, you know, I could pass in f here if I wanted. It's got the wrong parameter type, so it won't compile. It's going to be mad at us, right? Because it doesn't have a, it's supposed to return a Boolean, et cetera, et cetera. But you can pass function objects to sort. So if I wanted, I could do this instead. There. Okay. Makes the code maybe look a little bit cleaner, arguably. Some people don't like having, you know, you're reading a function call and suddenly you've got a page of text, you know, right there inside of your function call, and you're like, where's the closed parentheses again? You know, like, here's the open parentheses, and you're like scrolling down, you're like, where's the closed parentheses? You know, so there are times where, you know, you might want to just save the lambda into a function object, and then you can just pass the function object to the sort function. It's up to you. Now you're right, but we're still having to give it a name, right? Well, kind of. We don't give it a global name. It's got a name that only exists within this scope. So I don't have to worry about any other person in my entire organization having made a function called comparatore, right? Like, not at all. Like, any variable I declare here within my scope will shadow any existing f or f2 out there. So it doesn't even matter what they have. And I can just make a variable called f2 and pass it to the sort. There you go. And again, I don't have to create a global function eating up global namespaces, names, and things like that in order to get a custom sort function. I can call f just on its own if I wanted. Watch this, f. Everybody, could I get an f in chat? Thanks, you guys. Yeah, what happened here? What happened? I did something. Oh, the. Here you go. Compile, run. Stack smashing detected, terminated. What the heck went on here? I don't know what's happening here. Stack smashing detected. There we go. Okay. Definitely enough in chat after that. I have no idea what that was. Okay, so do you see this then? So we made a function called f, and this function only exists inside of main. Can't call it anywhere else. So it's kind of cool. And this is probably good practice if you have a function that only if you have a function that only gets called within one scope, make a lambda inside the scope, right? And then you can actually see the thing that you're calling. It's right there, you know, and you can call it, you know, however many times you want. You want functions outside of a function when they're being called by other people, right? Again, you have a name when you want to have multiple people refer to it. Okay. Any questions about this, guys? No? Okay, so the question is, you know, what kinds of things could you lambda capture? Anything you want. Like any variable that is outside the scope of this variable that's up in the enclosing scope. Like I said, you know, you can just do that. Now the variable is available inside the lambda function itself. And if you capture it by reference, you can change it back up in scope. Sometimes people will have functions that like do algebra, and they can like lambda capture in various, quantities and things like that, so they don't have to be passed as a parameter. It'll just grab the quantities directly out of the enclosing scope. It's just you can think of it almost as equivalent to a function parameter, but it's not technically a function parameter. Yeah, like the example I gave was using as a counter. So there's another anonymous thing. You can make variables that don't have names. So we've got functions without names. We've got classes without names. And now we can have a variable with no name. You're like, but how is that useful? And the answer is like, well, let me show you. Point p equals 5.3, 2.1. Let's say we have a function here called double.product that's going to take in a const point, by reference p1, a const point, by reference p2, and it will return p1.x times p2.x plus p1.y times p2.y. Little dot product action for you guys. It's essentially, if you have unit vectors, it'll compute the cosine of the angle between two things. Very useful in game dev. Shadows, lighting calculations are, using dot products. If your hand is facing the light, it's fully lit. As it moves away, it gets shadowed. Dot product. Take a dot product of the vector to the light, the perpendicular vector of your hand. Look, lighting, 3D games, useful. So if we've got 2 points, so let's just call it P1, why not? And P2, and these aren't unit vectors. It's going to be the cosine of the angles times the lengths of the vectors. So it's going to be 10, 0. If we see out the dot product of P1 and P2, this is going to pass this point to dot product, and it's going to pass this point to dot product, and everything's going to be cool and happy, and everything's cool and happy, and we get a number, and we're getting smack stash. Let's pull this other stuff off. There we go. 53. Okay. So we are getting a dot product of these two things here. And cool, neat. But we had to make 2 variables for this. And if we're not going to be using those variables again, it would be really cool if we didn't have to use the name P1, P2. So instead, I could actually pass directly into here point 5.3, comma 2.1, and point 10 and 0. And I will get the same result. You see that? I'm actually making a brand new variable. It's calling the default, the compiler will generate constructors for you if it's a pods, right? Plain old data structure. And what this is doing here, it's making a variable. What's the name of the variable? There's no name. There's no name at all. It's just making a new variable and passing it to dot product. And then dot product does the computations, returns the result, and then those variables go poof, and we can't see them again. But it doesn't matter because we don't care about them. We're not ever using person 5.3 2.1 again, and we're not using point 10 0 ever again either. If this is the only place where those variables appear, we don't need them to be separate variables like we had before. Now you might be asking, what's the difference between using curly boys and using smooth boys here, right? In this case, nothing. Yeah, it'll do the same thing. Curly braces in general are a little bit more strict. So if you have integer x and you set it equal to 5.3, 5.3, you'll get a warning, but it'll just warn you like, hey, by the way, you're losing the 0.3. You typed it. Maybe it's important to you that you have the 0.3 there, but it's valid C++. But if you do this with curly boys, now it's actually a compiler error. Okay? So curly boys enforce a stricter typing system. So with the curly boys, 5 will work, but 5.3 won't because it's an incompatible type. And so in general, people recommend that you use curly braces. You also don't need the equal sign. That is perfectly valid C++. So X with curly boys to 5. A lot of people like initializing their code that way. If you omit the number in the middle, it'll initialize it to 0. So this is the same thing as saying integer x equals 0. Some people prefer just the curly boys. Some people like equals 0. Makes no difference to me. They both set x equal to 0. Now, here, with the smooth boys and the curly boys, you would think like, oh, well, that's a int and that's a double. Double y is equal to 1. It's fine, actually. So in other languages, this wouldn't work. So like in, if you've ever done shader programming, you can't actually just convert an integer to a float. If you do Rust, it won't convert for you. Like, it's like, no, you told me you want a double, you got to give me a double. And so you would have to type in 1 with a dot after it, which is the same thing as typing 1.0. C++ allows that. That's because it would be kind of annoying to like get mad at people for setting something to 0. So they allow it. That also sets it to 0. If, however, you do, let's see, doing floaty. Yeah. So here we're getting a warning because 3.1 is a double, not a float. So if you put an F at the end of it, it'll be a float, and it will be perfectly happy. So like I said, if you do a float in there, it doesn't like it. But if you put in parentheses, it'll work. So the smooth parentheses are more tolerant of type conversion things, even though here you'll see the compiler does warn about it. Curly boys are a little bit stricter, but they're not as strict still as in Rust or GLSL or other languages that don't just convert willy-nilly from floats to ints and ints to floats like C++ does. Okay. You guys understand this? So we made a variable with no name and a variable with no name and passed them in. And then after the line of code is called, we have no way of seeing those people again. They're gone. Make sense? Kind of do this with vector, like you have a vector of integers named vec. See vec dot push. Actually, let's make it a vector of points. Why not? And so you'd say vector of push back. You can actually just push back just like this. You guys see that? So this is I don't even need to say the word point. Because in this case, we know the function parameter is point. In fact, I can come up here and just delete that, and it'll still work. Because it knows the type is point. And so when I pass in curly boys like that to it, it'll automatically construct a point for me and pass it in. With parentheses, it won't. Because parentheses are an expression, and so this turns into the number 2.1, and it doesn't convert. So curly boys are a little bit more useful maybe in this sense, because you can just construct the x and the y. So it's gonna add to our vector. X is 4, y is 3 in the slot vector.add 0. You guys understand? Give me a thumbs up on chat if this makes sense to you. I like writing code this way just because if I want to just make a bunch of points, do 10, 10, 10, 10, 40, 30. You know what I mean? Like you can just sit there and just push points into it, and you don't have to make a variable and then do a pushback and make a variable and do a pushback. It gets really annoying if you keep coming up with new variable names. It's just easier to not have to come up with names. That's the whole point of this lecture. Okay. Cool. So that brings us to the end of the anonymous lecture, and we'll be moving on to the next one.